So today we're going to look at reflection and refraction, and we're going to do so by putting this one beam of light, as you see here, on this spinning little table. And we're going to use it to figure out the angle of incident and angle of reflection and the angle of incident and angle of refraction. Now today I am not going to give you any data. I want you to read the data right off this video. That should be more than feasible. So when you look at the data table and see it blank, that is why. Now for the first bit, part A, I'm going to do reflection. What I'm going to do is I'm going to take a flat mirror and I'm going to line it up with this component line. And what I'm going to do is I'm going to change the angle of incident. I'm going to start by making the angle of incident 20 degrees. What I would like you to do is record the angle of reflection. And you can just take it by the value that the line points at. So there's for 20. There's for 30. I'll see if I can zoom in a little bit. And there's for 40. So record those angle of reflections. For the next part, I'm going to do refraction. And I'm going to put a piece of acrylic right in this little drawing it had for it. And what I'm going to do is I'm going to go to various angles, and for each angle, I want you to record the angle it comes out. Once you have the angle it comes out, we can go and basically try to use Snell's law. You see, we know if we find theta 1 and theta 2, we can find the sine of theta 1 and the sine of theta 2. We're literally just going to take the sine of each angle. And once we get the sine of each angle, what I want you to do is solve for the index of refraction for this. Basically solve for n2, assuming n1 is L, which is about 1. Of note, this is only going to refract once when it hits the flat edge. It would never refract when it hits the curved edge. Due to the shape of the curve, it's always going to be at 90 degrees as it leaves. So here we go, coming in at 10 degrees. And once again, I will zoom in. So that's when I come in at 10 degrees. This right here is when I come in at 20 degrees. This right here is when I came in at 30 degrees. This is 40 degrees. $50. 60. 70. So record all those theta 2's. Once you get theta 2's, find the sine of all theta 1's, find the sine of all theta 2's. And you will be making a graph today. What I expect you to be graphing is the sine of theta 1 versus the sine of theta 2. The slope of the graph should be the index of refraction of the acrylic. So you can find that like that. It's a quick one. Have fun.